identifying the states of matter and the phase changes. Before we delve in, let's have our lesson objectives. So by the end of this discussion, you can say that yes, I can identify the different states of matter, and yes, I can describe the phase changes that matter undergo. Now, before we delve into our discussion, let us have your review on what matter is. Now, in Module 1, we have discussed that matter is anything that occupies space and has mass. Now, it turns out that matter can have different forms. In physics, a state of matter is one of the distinct forms in which matter can exist. Observably, we have four. We have your solids, liquids, gas, and plasma. These are the different phases that we can see with our own eyes. We have our fifth state of matter, which is Bose-Einstein condensate, which only exists in extreme low temperatures. There are many other states of matter that was not included here, such as your glass, your liquid crystal, neutron degenerate matter, and quark-gluon plasma. However, we will only focus on these five. Now let us have a brief discussion on the following states of matter. Matter in the solid state maintains a fixed volume and shape, so that means they have a definite shape and volume. With component particles such as atoms, molecules, or ions, they are close together and fixed into place. Matter in the liquid state maintains a fixed volume, so their volume is definite. However, their shape varies. So that means whatever the shape of their container is, they will take the container's shape. Their particles are still close together, but they can move freely. However, compared to the gases, the particles of the gases can freely move around. Aside from that, matter in the gaseous state has both a variable volume and shape. So that means whatever the volume and the shape of their container is, that is what they will take. It will adapt to fit its container. Matter in the plasma state has variable volume and shape as well, such as your gases. However, it contains a significant number of ions and electrons, both of which can move around freely. Plasma only exists in places where the condition or the temperature is very hot. If we are going to compare that to Bose-Einstein condensate, it is the exact opposite of plasma. Now, plasma exists in very high temperatures, whereas Bose-Einstein condensate can only exist in very low temperatures or temperatures nearing 0 Kelvin. If we are going to compare the arrangement of their atoms or the movement of their atoms, the atoms for your Bose-Einstein condensate behave like little waves. That is because, due to the low temperature, the particles cannot freely move around, or the movement is pretty limited. In the solid state, the molecules are fixed in lattice or in a crystal formation, so their particles are close together and they cannot freely move around. If you're going to compare that to liquids, the molecules of the liquid are free to move because of the spaces in between these molecules or these particles. In gases, the molecules are free to move over a large space. The molecules of gas particles are free to move and that their spacing is pretty large. In contrast to your plasma, the ions and electrons move independently and that there are large spacing in between. In plasma, due to the high temperature in which these particles exist, the atoms, composed of your proton, electron, and neutron, actually separate, now turning to ions. So plasmas are actually charged particles. Among these five, the most common, as you can see here, are the plasmas because stars are mostly composed of ionized gas. The least abundant among these phases of matter is your Bose-Einstein condensate. This is because there is relatively or virtually no place in the universe where the temperature is near 0 Kelvin or absolute zero. Now, 0 Kelvin is equal to negative 273.15 degrees Celsius. You may have already found out that the changes or the differences of the phases of matter relates to the amount of energy in the form of heat it has. The higher the heat or the higher the energy, the greater the movement of the particles will be. So because of the heat, the particles become more excited, so it changes its phase from solid to liquid and then to gases and then ultimately to plasma. In the lack of heat or in low temperature, the particles will lose its energy and therefore will lose its ability to move around. Now, as you can see here, the amount of energy in the form of heat or in increasing the temperature, the phases of this matter can change. For example, a block of ice, which is a solid, can become a liquid once it absorbs enough energy. When you heat the liquid or the water, then it will turn into water vapor, which is now under gases. When the temperature of this gas is increased, it will now turn into plasma. The subatomic particles, the proton, the neutron, and the electron, could separate, therefore creating ionized particles or ions. Such is the definition of plasma. We have your three most common states of matter, which are your solids, liquids, and gases. We can actually differentiate these three according to their characteristics, such as shape. For the shape, solids have definite shape, whereas for liquids and gases, they take the shape of their container. For the volume, solids have definite volume due to their closely packed particles. For liquids, they also have definite volume. For gases, it takes the volume of its container. What about for the density or the degree of compactness of matter, or how their particles are arranged? For solids, the particles are closely packed with each other, so it is usually very dense. For liquids, it is less denser than solids because their particles can freely move around. For gases, it is usually much less dense than solids and liquids. There is so much spacing in between their particles. Next is compressibility, or the capacity of matter to be flattened or reduced in size by pressure. Now imagine a chalk. Try squeezing a chalk. So when you try to squeeze it, it almost does not change its shape. So therefore, chalk as a solid is not easily compressed. For liquids, if you're going to put liquid or water in a balloon and try to compress it, it is not easily compressed. For gases, it can be easily compressed. What about for diffusion or the ability of matter to spread out or transmitted to? Now, for example, for solids, if you're going to put food coloring on the chalk, the color will not easily spread out, or it will take some time for the food coloring to spread out. If you're going to put food coloring on water, which is a liquid, you can see it diffuse pretty easily. Now, for gases, the particles easily diffuse. An example of this is when your friend wears a perfume. You can actually smell your friend's perfume even if you are a meter apart. Therefore, the diffusion of gases is very rapid or it diffuses very easily. So that's it for Module 2. You can now try answering the different questions in your module. After that, you can check your own work.